Alright, so in this video I'm going to try to show you how we can take a derivative of a trigonometric function using the limit definition of the derivative. So let's go ahead and write out that limit definition right here. So we have f prime of x is equal to the limit as h is approaching 0 of f of x plus h minus f of x over h. Now we're going to use this definition and we're going to try it on the function sine of x. Alright, cool. So we'll say y equals sine of x. That means that y prime equals the limit as h is approaching 0 of sine of x plus h minus sine of x, all that divided by h. Now we can take this and use an identity on it and turn that into sine of x times the cosine of h plus the cosine of x times the sine of h. Alright, cool. So yeah, that substitute there, minus sine of x, and we're dividing all of this by h again. Okay, don't forget to drop your limit down, very important. Okay, so let's go ahead and simplify this a little bit further. So we're gonna end up with, let's see here, let's take these two terms with sine of x out and we'll separate those. So we have the limit as h is approaching 0, and we'll do, alright, let's see, cosine of x times sine of h over h and we can actually split this limit into two using our limit laws, which I don't think I made a video about this, but we can. You can go back and cover, look at it in the book. There's several limit laws. One of them says we can split limits up over addition. So we have plus sine of x. Well, actually just plus the limit as h is approaching 0 of sine of x. Okay, and we factored that sine of x out of cosine of h minus 1 divided by h. Okay, so we got two limits to take here. Let's go ahead and take this first one right here. So it's difficult. I'm not probably going to prove this here, but we can kind of get an intuition for this. Where we have sine of h getting closer and closer to h as the angle gets smaller and smaller. So this is something we call a small, I'll just use a small angle approximation, where sine of that angle h is approximately equal to h for very small angles. So using this, as h is getting smaller and smaller, it's going towards 0, then that sine of h is actually approaching h. So if we say that sine is approximately h, we can just cancel this out, call it h, and then you can see that these two cancel out, and this whole term goes to 1. Okay, so if this one goes to 1, that'll just give us cosine of x, and then let's go double check this other one. So we have cosine of 80. So we say the limit as h is going to 0, if this is going to 0 and this number in the top is certainly going to be smaller than whatever h is, that means that the bottom is rapidly outpacing, or in other words, the bottom is rapidly going much faster to 0 than the top is.
Strike that, reverse it.
Therefore, this whole term is going to go off to 0. Now, there's probably a proof for this on Khan Academy or somewhere else on the internet. You can find a proof for this, but just by intuition we can kind of deduce that this is going to go off to 0. So using these deductions, this whole term goes off to 0, and we're simply left with cosine of x. Okay? So this is how we can prove a trigonometric derivative. Well, this is how we can derive a trigonometric function's derivative using the limit definition of a derivative. Now, in the next video, we're going to talk about the rest of the trig functions and how we can derive those derivatives and go from there. But it's very important that we understand the trigonometric derivatives, how we derive them, but most importantly, you're going to need to memorize these. So the trig derivatives, you won't almost certainly need to know that the derivative of sine of x is equal to cosine of x, and that's what we've proven in this video. So there's that. We'll go on to the rest of the trig derivatives in the next video.